Good day to you. My name is Nicholas Zandigu, and today I'll be discussing the processes of X-ray crystallography and how they may be used for determining the structure and function of proteins. First things first, it is important to know about crystals before discussing X-ray crystallography. A crystal is a naturally occurring structure formed from atoms that are ordered very specifically in the form of a lattice. They usually take the shape of a rectangular prism or cube. The total structure is made up of many unit cells, which is the formation the atoms take without repetition. X-ray crystallography is the most widely used method for determining the structure of proteins at the moment. The general process is to grow a three-dimensional crystalline structure of the protein, ensuring the crystal is as pure as possible. This crystal is then spun and targeted with an X-ray beam, whereby the electrons will cause the X-rays to bounce off them. This phenomenon is known as diffraction. Ultimately, this diffraction of the X-rays reveals where an electron is within the crystal, as well as how dense with electrons a particular part of the crystal may be. The data that corresponds to this is called an electron density map. This map can then be used to calculate the overall shape and structure of the protein that is surrounded by all these electrons. Additionally, since this method has been used for so long, there are computer databases that will provide its own analysis of the data to determine the most likely protein that was tested. For example, the case of human alpha hemoglobin sees Kumar et al. Performing an X-ray crystallography on the protein and analyzing the data by several methods, including computationally, automatically via a database, and cross-referencing with previous studies. Cryogenic electron microscopy is a comparable method to X-ray crystallography. This method involves the testing of radiation-sensitive samples under cryogenic conditions in a transmission electron microscope. While these two methods may be done in tandem, their differences may be reason enough to perform one over the other. Cryogenic electron microscopy is more appropriate for proteins which require less pure samples to be tested and does not need the protein to be prepared as extensively as those with X-ray crystallography. Additionally, cryogenic electron microscopy may be done within a standard laboratory, whereas X-ray crystallography is limited to synchrotron facilities. Conversely, if one obtains access into such a facility, X-ray crystallography is a much faster technique and provides an electron density map with a much higher resolution than that of cryogenic electron microscopy, allowing for a better determination of the protein structure. Yet, due to the accessibility of cryogenic electron microscopy, it is expected to surpass X-ray crystallography as the more prominently used technique. To summarize, X-ray crystallography is an important technique in the determination of protein structure through its principle of diffraction. Once determined, these structures may be further studied to acquire information on protein function or interactions with other proteins. Thank you for watching and have a good morning, afternoon, or evening.